getting smaller now. Okay, are getting smaller. So what I did the same thing I did yesterday for addition with you guys. I got a line segment A equal to line segment B. C and D are equal, but now I want to subtract. All right, so I'm going to ask somebody, can you give me pairs to subtract that would be equal to each other? And just before you let me know that, I'll let you guys know A and B are the bigger segments. All right, so you don't want to go C minus A. That's kind of impossible. Right, that's impossible. So I will let you know that A and B are my bigger segments here. So give me a combination of segments to subtract up here. Again, A and B are my bigger ones. How about a combo to subtract up here? Let's start on the right foot. Violet, what do you got? What do you want me to subtract? From these pairs up here, which pairs do you want me to subtract from each other that are going to be the same? Same as addition yesterday, but now we're just subtracting. Okay, so A minus D equals B minus C. Yep, that's fine. Everyone agrees? Those new segments would be equal when I subtract those. We're in honors, so let me do another pair. Or what else could I do? What other segments could I subtract? Remember, A and B are the longer ones. Kevin, what do you got?
A minus B equals B minus D.
Yep, I like it. But now we call that subtraction. And we call that subtraction. Questions there? All right, let's actually do a geometry one now using subtraction and talk why it's subtraction versus last week. All right away in the givens, you're welcome. I already wrote them down for you. Right away in the givens, angle DAC. Everyone look at that angle. What do I call that angle? Straight angle. What does it measure? 180. Remember that. It measures 180. I also have ECA, which is also a 180, so it makes sense that they're equal. And I also have angle 1 congruent to angle 2, which, as we know, mark with arc marks. First discussion, how do I know this is subtraction versus addition, right? How do I know that? Well, let's look at your givens to what I'm asking you to prove. You already told me how many degrees was DAC? 180. And look it, now I'm asking you to go to the proof statement to angle 3. Angle 3, everyone agrees, a lot smaller than 180. So does everybody see my angle in the given is getting smaller as I go to the proof statement, not bigger? And the same thing, I'm going from ECA, which you guys told me was 180 degrees, to angle 4, which is clearly not, it's clearly less than 180. So does everyone first see we're getting smaller? So that tells me to use subtraction versus addition. See the difference? Yes, when I know, because that's going to be the toughest part about today is which one do I use? How many quantities did I give you?
2.
So can I subtract in number statement 2?
Yes.
Yes, I can. You just got to tell me correctly what I'm subtracting to get to angle 3 and 4. All right, so what 2 angles do I subtract to get to angle 3? What 2 angles do I subtract to get to angle 4? So let's start here. I need 2 angles that I'm going to subtract to get to angle 3 that are already given for you. It's already up in the givens, just got to put them together. Well, the big angle would be what? I'm trying to get to angle 3. Angle 3. So the big angle I'm going to start out with is angle. Yep, and what are you going to subtract from it to get to angle 3? Angle 1. Good. Right, everyone, if I cover up, subtract angle 1, I get angle 3. And that is the same as, what other pair am I going to subtract up here to get to angle 4 now? What pair do you want me to subtract to get to angle 4, Jacob?
ECA minus angle 2.
There you go. Equals angle ECA minus angle 2. And that is by what property now? Subtraction property, right? Hey, guy, you put the darn symbol there. All right, you put the darn symbol there telling me you're subtracting. I promised everyone yesterday, anytime you wrote down addition through the course of the year, very next reason was always what? Subtraction. Substitution. Same thing. If you add or subtract, I promise you the next step, you're going to show me what you're substituting in, right? For addition and subtraction. So we are going to use substitution again. Now, what am I going to substitute in for DAC minus angle 1? That would be what angle's left now? Angle 3. And ECA minus angle 2, that's going to be angle 4. Does anything change from addition yesterday? Nope, just got to determine which one it is. All right, got to determine which one it is. Any issues here? I got one more, maybe subtraction one, maybe. I know it's subtraction day, but maybe I threw a little trap in there. You never know. All right, DF and BE are congruent. Can we mark that somehow? I know this is a little bit tougher to mark. I don't care how you do it. Just make sure you know you're marking DF and BE equal, right? So this is how I'm going to do it. You guys do it however you prefer. So those two are equal. Look at your segments in the given as we go to the proof and say to yourself, are those segments getting smaller or bigger as I go from the given segments to the proved segments? What do you guys think? Am I getting bigger or smaller?
Smaller.
Okay, you answered the question already. You already know what type of proof it is. It's subtraction. Problem though? Problem. Only one pair, right, of equal quantities. So statement 2 is not going to be subtraction. We need to find the pair that we need to subtract from each of them. So let me start here. DF, everyone look at segment DF to DE. DF to DE. What's got to come off? What's got to subtract from that one? Zach? EF. Good work. And now let me go to the other side. What do I need to subtract from BE to get to BF? What do I need to subtract there from BE? Ones, Aditya? From BF, what do I need to, from BE, what do I need to subtract to get to BF? EF as well. And what do we know about EF and EF? Well, they're congruent, right? Because of reflexive property. Did I talk about having self-respect when spelling the word reflexive yesterday?
No, you talked about.
Okay, vertical, right? We had talked about having self-respect. CAL at the end, not CLE. Reflexive has no S in it. I hate to break it to you. All right, it has no S in it. It's not reflexive. All right, reflexive. And it's not reflection property either. I will take off of that one. It's not the reflection property. We're not trying to see you when you bike at night. All right, and I just started writing it. Whoa! I hate that so much. I did that. Zip it. Ha! No. All right. All right. I'm back now. Act like you're teaching honors kids, Mr. Carlino. Now, do I have two pairs of equal quantities?
Yes.
Yes, I do. Now, what can I do? Subtract them. Make sure it's in the correct order. Bigger one comes first. Give me a pair to subtract. Give me a pair to subtract. Oh, here we go. Aylin, give me a pair to subtract. DF and EF. So DF minus EF is the same as subtracting what other pair up here? 1, 8. Kevin, back to you. BE minus EF. Perfect. And now be careful. And in all seriousness here, you know what I get a lot of?
Substitution.
Yeah, kids write substitution here. All right, make sure it's subtraction. Then we can do substitution. There it is. Now you guys just got to figure out which one it is. Please ask anything because I'm hoping right now everyone feel confident, comfortable with these, warm inside. Do we feel that way? Because I'm about to crush your dreams.
Oh yeah.
Okay, I'm about to crush it. Everyone good? All right, we are taking a total left turn here for this last property. Before I introduce it, let me ask you a couple questions based on my segments up here. Okay, I'm going to tell you they're congruent. Here's what I'm going to do. These congruent segments, I am going to cut both of them in half. What do I know about the halves now? Are they congruent?
Yes.
Okay, why are they congruent? Because I started out with equal segment, congruent segments, and I did what to them? Cut them in half, correct. So that's our last one today. It says, if I have congruent segments, or if I have congruent angles, I can have either one, and I cut them in half, the halves are now congruent. That's our last fact for today. The concept makes sense. If I have two congruent segments or two congruent angles, and I cut them in half, their halves will now be equal. Good? All right, let's start with a basic one then. Basic one using this. What do we got? Pinwheels. I'm not even going to go into the name of it. I'm going to hop right into the proof. So what did I give you right away? I have two segments, AB and DC, that are congruent. You don't have to do a diagram. I'll just show you quickly up here. So I have AB, DC, there you go, AB, DC, and they're congruent to each other. I'm going to take half of AB and call it what? I'm going to take half of AB. What's my new line segment called? Good so far. I took half of it. I'm going to call it AF. And I'm going to take half of DC and call it what? EC. What should I know about those halves then? Makes sense, right? We just got to put a name to it, an official reason to it. But does if the wholes were equal, the halves will be equal. Yep. All right. So the reason now, well, which halves are equal? AF, well, all of them, but in this case, AF and EC. So I can say AF is congruent to EC. And here's our official and our last one for today. Halves, because that's what I took, right? Halves of equal quantities. And just so we're all on board here, when I say the word quantities, I mean angles or segments. All right, in this case, it's segments. So halves of equal quantities are equal. Okay, that is our new property for today. If I take half of two things that were already equal, those halves will be equal. Questions there? Whoa, 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 whoa. I got a question or two. Geometry. Did you have a question, Violet? Go ahead.
If you have that congruent segments, and you got an equal piece of each one, but it isn't half, does that rule still work?
No, it's only for halves. It's only for halves, not thirds, fourths. It's only for halves because that's the only thing we're going to deal with is halves. Okay, and that brings me to my next point. It's going to be rare that I tell you we're actually cutting an angle or segment in half by showing you half. Two vocabulary terms we talked about last unit that automatically tell us that something's being cut in half. So if I see these vocabulary terms in the givens, I can already say to myself, oh, it's being cut in half. I don't need to be told it's being cut in half. I already know because I see these two vocabulary terms. Here, one vocabulary term, bisect. So if I see an angle or a segment is getting bisected in the givens, I know I'm taking half of it. Bisect and, Colin, you got the other one?
Midpoint.
Midpoint. So if I see those words in the givens, that should signal to me I'm taking half of something. All right, because probably I'm not going to tell you I'm taking half. You guys got to figure that out by the vocabulary terms. Which brings us to our last proof for today. Here we go. Swing. Everyone see it. CA bisects DCB and DAB. So what am I doing to DCB and DAB? Cutting in half. I don't have to write that for you. We got to know that based on that word. Also, I'm giving you two congruent angles. Mark them on your diagram. Mark those congruent angles on the diagram. DCB and DAB. Do not, I know this is a little bit different setup. I wrote all the givens in for you. And then the proof statement is R congruent to S. Those are not congruent. Those are ones we need to prove. So is everyone marking I don't know why we have hash marks on our diagram. I don't know why we have hash marks. None of the segments are congruent. Just two angles. We should have two arc marks on our diagram. That is it. And those arc marks should go here, DCB, and DAB. All right, let's talk this through before we put anything down in statements, reasons. We know those two angles are congruent. We also know what else is happening to those two angles we just marked congruent. They're cut in half, right? Which means their halves must be equal. See where we're going here? The angles were equal. You're going to cut them in half because of bisecting. So the halves must be equal. All right, it's not a two-step proof, though. It's not a two-step proof. You need to tell me what you're cutting in half and what you're calling that. All right, give me one angle we're cutting in half so I can start this proof here. One angle we're cutting in half. 1, 9, I'm going deep here. Here, one angle I'm cutting in half.
DAB.
DAB, so everyone ready? 1/2 of DAB. Kira said you're cutting DAB in half. I'm showing you that. Half of DAB is equal to, now, I have two options right now what I could call this half. Everyone look at DAB. I could call it DAC, or I could call it angle R. Both would be correct, right? Because both those angles are 1/2 of DAB. So right now, after my equal sign, I could write DAC, or I could write angle R, but we only care about one of those in the proof. Which one of those two do I care about? Which one?
R.
Which one?
R.
What are you, pirates? All right, moving on. Angle R. Good. He's got jokes for dad jokes for days. All right. Favorite vacation spot of a pirate?
Oh, Caribbean.
No.
Caribbean.
No. Jesus. Your honors.
Oh, I got it.
Country?
Oklahoma.
Oh.
No. You're killing me.
Armenia.
No.
Arkansas.
No. Country. Country.
Oh. Argentina.
Thank you. Argentina. Thank you.
Yay,
Favorite
yeah.
restaurant for a pirate to go to?
Arby's.
Arby's. Yes. No one's getting this. Favorite movie?
No. Oh my
No. Anything rated
R.
Yeah. Let's go. Let's go.
God.
Let's go. All right. There's the first statement. Aren't I cutting another angle in half? Yes, I'm cutting another angle in half. What's that other angle I'm cutting in half? Connor?
The angle. Well, DCB.
Got it. So 1/2 angle DCB equals, now take a look at your diagram. Again, I have two choices, don't I? I could call half of DCB DCA, or I could call it angle S, but pick the one we're using in the proof. In this case would be angle S. So I'm showing you I'm cutting an angle in half and what I'm calling it. Now, the reason is not halves of equal quantities are equal. What is the reason why you knew you were taking half of those two? How did we know up here? Something up here told us you were going to take half of DAB and DCB. What up here told us you better take half of it? Odin? Something in the givens told us you're going to be taking half of these two angles.
CA bisector.
Definition of
Bisector.
bisector. There it is. You have to write down what you're taking half of. Well, Mr. Carlino, you didn't have us do that for the last proof. We didn't have to write down what we were taking half of. I know, because anybody? I gave it to you. So if I don't give this to you, you need to write it down. All right, before you finish the proof. Make sense? You need to show me what you're taking half of before you finish the proof. Speaking of finishing the proof, I'm taking half of two angles, which we knew were congruent. So what do I know about the halves I just called R and S? They're equal now. And that is halves of equal quantities are equal. Before you go to the homework, I can't stress this enough. You cannot use, try that again. You cannot use this property unless you tell me above what you're taking half of. Will it be given sometimes? Sure. Do you have to write it sometimes? Yes. But how are you going to know it's a halves of equal quantities proof? What are you going to see in the givens? Bisector or midpoint. All right, that's a dead giveaway. Warning, tonight on homework, might have snuck in an addition proof in there. Just saying, be on your toes, honors kids. All right, it's not all subtraction. All right, might have snuck in an addition proof in there. Go ahead and get going. If you have questions, let me know.